Hi there! Welcome to the 46th episode of the Synth project, where we are building a synth together. We have finally arrived to the last episode of the construction of the MIDI module. Although it is not an analog module, it is a very important piece for our synth because it provides the meaning of generating various kinds of control voltages for handling all possible modules of the synth itself. And that is done by using external MIDI devices like keyboards or drum pads or whatever else we can think of that can generate some significant information for the analog synth to use. In this episode we will go through the process of designing and assembling the MIDI module in a case suitable for our synth rack, and we will use it to do some experimentation using both an AKAI LPD8 pad controller and a Yamaha DGX505 keyboard. Let's begin! Here is the case I designed for the MIDI module. It is not one of the biggest we made, but it is very crowded and packed with a lot of circuitry. On the front panel we find the holes for the 2 rows LCD, then a set of push buttons that will be used in the future to access a number of functionalities that will be implemented with software in the future as they become useful. There is an extra button with respect to my original design, a late addition for a menu button that I thought it will be useful to ease the navigation of the various functionalities that we will create on this module. Follow 12 holes that will be used for 12 distinct jack sockets. In the first row we will have the control voltage for modifying the pitch of a VCO, the velocity control voltage, and the gate and trigger signals, which are similar to those we have in the keyboard module. The remaining 2 rows of jacks will provide control voltages to handle the various capabilities of the synth. These control voltages are generated from the control change MIDI messages, generated when we use the knobs of a controller, like those in the AKAI LPD8. I have actually decided to have 8 of these outputs, so I can fully use all the knobs in the controller I own. Those rectangular holes toward the bottom of the panel will be used for the USB ports of the module. We will have 3 USB ports, one for connecting a MIDI device, which will be the one on the right, one for the program updates to the module, which will be the one on the left, and an auxiliary port in the center connected to the native USB port of the Arduino Duo inside the module. This port will not be currently used, but I plan to do something with it in the future, like having the possibility to attach a USB drive to read-write sequences of MIDI messages from memory, to store and reproduce entire melodies from and to the synth. On the back of the front panel I added a number of standoffs embedded directly in the panel's body. They will be used to hold in place the various boards needed for our project. There are 4 standoffs for the display, 4 standoffs to hold the push buttons board, and finally 4 more standoffs to hold in place the board with the USB connectors. On the side panel we find the holes for the Arduino Duo and for the PCB I designed for this module. Here is the perfboard where I soldered the push buttons we need for our circuit. I was thinking initially to attach 4 standoffs to the board and make 4 holes on the front panel to screw the board on it. It was only later that I decided to incorporate the standoffs in the design of the module case, and so I later removed those black standoffs because they are useless. Even if you don't see it here, I also added to the back of the perfboard a pin header and connected all the push buttons to it to make it easier to do the wiring inside the case. And here is the front panel again, with all the elements already assembled in it. See how neat is the panel with no extra holes and screws visible from the front? This one is the layout of the PCB. All the components used in this project find their place on this board, except for the resistor that handles the extra push button that I added for the new menu button, which I decided to add after I have ordered the PCB. That's not a real problem, because I was able to connect and solder the resistor to the push buttons board directly. Since this board needs to connect to both the Arduino and the power rails of the Synth rack, I ended up mounting on it two different kinds of pin headers, the majority of them compatible with the Arduino headers, and one compatible with the connectors of the power rail. I also used the same pin headers needed for the Arduino to create the sockets for two small logic level adapters that bring the Arduino 3.3V output levels to the 5V necessary for the LCD and for the trigger and gate signals. I also used regular IC sockets for all the other ICs on the PCB to make it easier their replacement in the remote eventuality one of them needs to be replaced. The PCB is also made in such a way that all the headers toward the Arduino are on the same edge of the board, while all the headers that connect to the components on the front panel are on the opposite side edge. The board is packed with very small space around, so the leads of all the components need to be bent very close to the body of the components themselves. Also, to save time, I ended up inserting entire batch of components and then solder them all at once, rather than going one component at a time. And this saved me a lot of time. Here is the PCB with all the resistors already attached to the board. And here is the same board after all the capacitors were soldered on it. Semiconductors were the latest I soldered to the board, as I usually prefer to do. In fact, I even kept for last the 9V regulator, which I soldered after fixing a heatsink on it. Finally, I added all the components that needed to be inserted into sockets, the level adapters and the integrated circuits. And this is the complete board. Well, almost. There was still missing a whole row of pin headers. I did not connect them until this time, because I was thinking originally of soldering one side of the wires directly on the board and the other side of the components directly on the front panel. However, before starting wiring everything together, I made the final decision to put pin headers everywhere to make it easier the replacement of components in case of future component failures. And here is the module case with all the components on the panel and the board screwed to the side wall. Note in particular the Arduino and the USB host shield to the toe attached on top of it. This time I attached the decals on the panel only at the end, rather than doing earlier and covered them with some clear paint. I wanted to use the same technique I adopted for the power supply panel I built recently, which is faster. I discovered this liquid in a hobby store. It is mostly acetic acid. You first apply it on the surface where you need to put the decal, then you put the decal, and finally you brush some more of it on top of the decal. The result is similar to what I have obtained in the past, but it is much faster to execute, since you don't need to spray several layers of clear paint on the panel, waiting that it dries out between one application and the next. Here is the final result, with the completed panel visible in all its glory. Once all of that is done, the wiring is a very simple thing to do, because we only need to put DuPont wires between the pin headers on the PCB and the corresponding pin headers on the Arduino, or one of the boards on the back of the front panel. Just make sure to follow the schematic while you do so, and there will be no problem. If you find that some of the pin is a little loose in its socket, just thicken the pin laying a thin layer of solder on it. It will work very well. Remember to connect also the extra push button for the menu capability. That button, like we said, is not directly connected to the PCB because it was a late thought, but just follow this additional circuit to attach it directly to the Arduino pins with the additional 470 ohm resistors on the side of pin A11. To test the module as a whole, I connected it to the AKAI LPD8. First I tested all the push buttons except for the menu button, for which we don't have any software yet. Then I checked that the MIDI module would recognize all the MIDI messages emitted by the LPD8. And finally, I used the digital voltmeter and the oscilloscope to verify the value and shape of all the emitted signals. Once I was satisfied with all the test results, I installed the MIDI module on the synth rack. It is worth noting, and maybe you already realized that looking at the latest version of the schematic and the software, that the last change control output is no more associated to data pin 9 of the Arduino 2. I actually moved it to data pin 11. If you are wondering why, the answer is timer interactions. The pin 9 I initially planned to use is in fact controlled by the same timer that controls the USB host interface. As a result, pin 9 cannot be used along with its PWM functionality, and since the same goes for pin 10, I ended up using pin 11 for the last change control output. Not a problem, of course, since it was just a matter of changing the slot on the pin header of the Arduino and making a small change in the software to use this pin 11 rather than the former pin 9. But I thought you should know. And now, time to make some noise once again. I have installed the MIDI module and connected it to the AKAI LPD8, which is right here. And the MIDI module is connected on its own through the VCO, and then there is a gate and trigger signal that go directly to the ADSR module, and the output of the ADSR module goes to the VCA incorporated into the VCO to handle a triangular wave. This way, when I use the pads of the LPD8, I should see sounds coming out of the VCO, modulated in amplitude through the ADSR. Let's try to do that. And I will concentrate my hands on the LPD8. Let's turn it on. The module is ready, and let's go. And the MIDI module seems to follow very easily the generation of random sounds requested from the LPD8. I increased the volume a little bit. Let's try now something else. Okay, let's see how this works with the VCO. Volume a little bit. Now I have disconnected the LPD8 and instead I have connected to the MIDI module the DGX505, and I will try to use that to play something. The MIDI module right now has the control voltage connected to the VCO and the gate also connected here to the control voltage for the VCA channel for the triangular wave. This way, every time I hit a key, the gate will go up and we will hear the triangle wave coming out directly with no modulation and so forth. Let's see what this brings us. I have turned down the volume of the keyboard itself, so the only sound is the one coming from the synth. This time I have still a keyboard connected to the MIDI module, but now in the MIDI module the gate and trigger input go directly to the ADSR module. It is its output that will control the triangular wave on the VCO. And let's see what that changed in terms of tonality, just because I have reinserted in the picture the ADSR. I foresee that I will use a lot this MIDI interface on the synth. In fact, it is a very simple way to control all the functionalities of the synth while playing something, once all the patching is done. Time now to start thinking to the next module for the synth. But do you have any suggestion for it? And what should I do next? Please let me know in the comments. And while thinking of that, I leave you with my usual happy experiments.